Hello, this is the conclusion to the lesson that we started in class today. It's just problem 7 and 8, talking about the Mayan form and turning one of our numbers into Mayan. And we'll see that there's a problem with their system, much like when we encountered with the Babylonians. All right, so like in the last section, what we saw happen with the Babylonians is that to turn our number into Babylonian, we had to use division. We have to do the same thing to turn our number into Mayan. So we need to know what the place values are. So we've already mentioned we have the ones place. We have the 20s place. And then we had 20 times 18, which was 360. Then we had 20 squared times 18, that's 7,200. And we'll go just one bigger. So if we take that 7,200 times 20, because that would be the next place value, we would get 144,000. And again, I won't write the comma in the middle of the 144,000 so that I don't accidentally separate it and make it look like 144. And then zeros. So these are our place values, and we take the biggest value that will go into the number that we're given. So we're given the number 208. The biggest value that will go into 208 is 20. So we do that division algorithm where we divide the 20 into 208. So 20 goes into 208 10 times. 10 times 20 is 200, which gives us a remainder of 8. And then we go down 1 in place value. So from the 20s place, we go down to the 1s place. 1 goes into 8 times. And 8 times 1 is 8, giving us a remainder of 0. So these numbers here on the side, oops, I put the 10 in the wrong place, so sorry. 10's over here. These numbers over here to the side, the 10 and the 8, tell us how we write our numbers. So a 10 is 2 lines. And then an 8 is 3 dots and a line. So this is the solution or the answer to our 208 turned into Mayan form. And then we've got the number 58,532. So the biggest value above that goes into that is actually 7,200. So we'll divide it by 7,200. So 58,532. This goes in 8 times. 8 times 7,200 is 57,600. And so when we subtract that, we get 932. And we want to keep going down. So from 7,200, we now go down to 360. So we'll divide by 360. And it looks like that goes in 2 times. So 2 times 360 would be 720. And 932 minus 720 gives me 212. And then from 212, we would divide by 20. So 20 goes in 10 times. So 10 times 20 would be 200. Giving me a remainder of 12. And our last division would be by the place value 1. And so with the 1's place value, it goes in, of course, 12 times. 12 times 1 is 12, and gives me a remainder of 0. So these pieces, again, over here on the right, oh my goodness, I did the 8 still at the top. There's an 8. There's where it's supposed to be. The 8, the 2, the 10, and the 12 tell me how I'm going to draw this. So let me shrink what I have on my screen and shift it over just a little bit so that we can draw it next to it. Okay, so an 8, as we just did before, is 3 dots and a line. The 12 is 2 dots. I'm sorry, the 2 is 2 dots. The 10 is 2 lines, and then the 12 is 2 dots and 2 lines. So this is, in fact, how you would draw it, and you might see some spacing, trying to separate out some of those place values. If we actually had a 0 showing up in the highlighted, yellow ones that we had there, we would draw the clamshell symbol. We don't have that in this case, but take a look at if I were actually separating this out the way we did on the last 2 problems. I would probably separate here because it goes from a 5 to a 2, right, 5 to a dots, or the line to a dots. And I would separate here because I have 2 dots and 2 lines, and I would have the last value. And it would look like this is the 1's place, this is the 20's place, and this is the 360's place, which, of course, it is not. Because there's nothing innate in their system that says, hey, oops, I really need to split it up here. And so that's a problem. Again, it's not a problem you're going to run into, but it is an inherent problem with the system.